Okay, so we are doubling up yet again with sections 2.5 and 2.7. So the last video was 2.4 and 2.6. So we're getting the in-betweens now, 2.5 and 2.7. This is all about formulas and problem solving. So we have two sections that have a different set of formulas each. 2.5 focuses mainly on these formulas, and 2.7 focuses mainly on interest. So this first one and then this other interest formula that we'll talk about down here. So I've combined these in two because, again, it's all basically the same thing. So we have two objectives in this section. We're going to solve a formula for a specific variable. And then second, we're going to use formulas to problem solve. So we have a bunch of formulas here that I've written out, and we're going to fill in at the end here the equation form of what that formula is. So starting with the interest formula, interest equals principal times rate times time. The principal is your initial value or initial investment or initial dollar amount. So that's always represented as I, and so it equals P times rate times time, or PERT. So this isn't, some of you might know what the PERT formula is, and if you don't, it's fine. We'll be going over it in a later section. But I like to call this the baby PERT formula. But this is also sometimes called simple interest because it's just a straight calculation of your principal times your rate times the time of the account. So that's our first formula, I equals PRT. The area of a rectangle, we all know, is length times width. So A equals length times width. Sometimes also base times height, you might have seen it as, mean the same thing. The distance formula, distance equals rate times time. So the D for distance is always lowercase d. And this equals rate times time, or sometimes we see this as, not a comma there, as speed times time. So rate or speed for this class are one and the same. Circumference of a circle. Circumference is 2 times pi times the radius. So circumference is capital C. 2, our Greek letter pi, and then times the radius r. For volume of a rectangular solid, otherwise known as a box, this is length times width times height, length times width times height, or also sometimes base times width times height. So these are our basic formulas that we'll need to know, and then we'll talk about this other one down here in a little bit. But for now, sometimes we don't want the given variable on the left here. Sometimes we want one of these inner ones. So we need to be able to solve for any given variable. And the nice thing is you treat everything but the variable you want as another number. So if I want to solve this for h, I'm going to divide by length and width, divide by length and width, and I'm going to get h equals volume over length times width. And I have a new formula for height of a rectangular solid. And so there's a couple practice ones here. None of these are designed to be difficult, just get you used to having to solve for other things, because a lot of times, like in this, we have the interest formula, but we want to know the principal because we know the rate and we know how long it is. Or circumference, we know what the circumference is and we need to use that to solve for r, because pi is a known number. It's 3.14 blah, blah, blah. And then some basic introducing multivariable equations here in the traditional sense, x's and y's. Sometimes we want x, sometimes we want y, so we need to be able to solve. And then another area formula here, which is the area of a trapezoid. And this capital B is the area of the base, and this little b is the length of the base. But again, you don't need to know that to solve for little b, you just have to be able to solve for it. So try those out. we are going to go in depth on our first example here with our big interest formula. So a couple received an inheritance of $10,000, plans to place all the money into a savings account that pays 5% compounded quarterly to help their son go to college in 3 years. How much money will be in the account in 3 years? So this is the compound interest formula. I did not spell compound right. And unlike simple interest, it does not tell us the interest. It actually tells us something better. It tells us the amount. So this A is not interest, even though we call this the compound interest formula. This tells us the amount. The R is still the rate. The N is a new term. This is the number of compoundings. And the T here is time in years. So we have a little bit more to identify, but we have all these things. Oh, I forgot the P. The P is still the principal, which is the initial. So the way these compound interest formulas work is I'll make a little key here and just go through step by step as I read my problem and identify what that's telling me. So a couple just received an inheritance of $10,000. Okay, that's an initial amount. That's going to be my principal, $10,000. Plans to place all the money in a savings account that pays 5%. So as a decimal, that's 0.05, because we always want our rates as decimals. We don't calculate with percentages. And it's compounded quarterly. Now we'll come back to that in a second. And they want to help their son go to college in 3 years. How much money will the account be in 3 years? So 3 years is our time. Remember, time is always in years, so that's a good hint. And they're asking how much money, which means that we are solving for A, so we don't need to solve this equation for any other specific variable. So now all that's left is evaluating the N variable. So compounded quarterly, this is your big hint here. Quarterly, there are 4 quarters to every year, which means if it's happened once every quarter, there will be exactly 4 times. 4 times per year. So I guess I should, this is the number of compoundings in 1 year, not all compoundings. That would be great if it was all compoundings. So quarterly means 4 years, annually means 1 year, biannually means 2 years, monthly means 12 times. What else? Weekly means 52. Daily would be 365. So those are the words when you're dealing with percentages and interest in business world and accounting. You're not going to see 4 times per year or 12 times per year. They'll say quarterly, monthly, triannually, which means 3 times a year, stuff like that. So keep a lookout for those. So now we're going to take our variables, plug it into our equation, and solve. So we have A equals our principal, 10,000, times 1 plus our rate, 0.05. Compounded quarterly means N is 4, times raised to the 4 times 3 years. So this is a calculator problem, so we would punch this into a calculator. 10,000 times whatever that number is to the 12th. So putting that in my calculator real quick here, 0.05 divided by 4 is 0.0125, so this is 1.0125 raised to the 12th. Raise that to the 12th, and then times by 10,000. And we get 11,607, and then a bunch of decimals. So we always want to remember, when you're dealing with money, we round to the second decimal place or the hundredths decimal place. So this is 4518. That's what I got on my calculator. So that means I'm going to look at this. I'm going to look at that. It's 5 or bigger, so I'm going to round up. So that means $11,607.55 is our final answer. So money, you always round to 2 decimal places because that's all we do. When we think of cents, you don't think about thousandths of cents. You would never say, I have 54.5 cents, because we don't go lower than a 1 cent piece. So that's our compound interest formula. It's more intense than the other formulas for sure, but if you just make your little key and make sure you're going through sentence by sentence and identifying which of these that is, you can break these problems down fairly easily. So on the back, we have one more example to go through together because, well, I'll talk about it in a second. So the fastest average speed by a cyclist across the continental United States is 15.4, in case you can't see it, miles per hour by Pete Pensires. Sure, let's say Pensires. If he traveled a total distance of about 3,107.5 miles, give or take about a mile, that's what it is from coast to coast, at this speed, 15.4 miles per hour, find his time and cycling. Find his time cycling, write the time in days, hours, and minutes. So, we are looking at speed, we have a distance, and we have time. That tells us this is our distance formula, d equals st or d equals rt. So now we need to identify what do we have and what do we don't have. dr, and I'm going to use s because they call it speed. So the distance, they tell us, 3,107.5. Oh, I did r and s. T and s. T, they don't tell us. S, they tell us, is 15.4 miles per hour. So T is what we're finding. So we can take this formula and solve it for T. So D equals ST, divide by S, divide by S. So T equals distance over speed. So our distance, 3107.5 over 15.4. So we have, throw this in the calculator, and we get T equals 201.79. So now the question is, what's the units on this? We know we need our answer in days, hours, and minutes. But what does this number actually represent? So to think about that, we're going to think of the units of our variables here. This was miles, and this was miles per hour. So over here, miles divided by miles per hour, means miles times hour over miles, using our fraction rules. This over 1, so this cancels, which means all we're left with is hours. Well, that means we need to convert this to days and minutes. So if we have hours, you ask yourself, how many hours in a day? 24. So we're going to take 201.79 and divide by 24. So when you do this in your calculator, you get 8.4079, and I'm going to round it off 7. Now, I don't know what 0.407917 days is, but I do know what 8 is. So I'm going to take this number here, and this is the number of days. And then I'm going to take this number, and I'm going to convert this back to hours. So to convert that, we just times it by 24 again, because that's how many we divided by. So times 24, this gives us 9.79 hours. And 0.79 is not great, so we're going to take this number and convert this in terms of hours, 0.79. I couldn't tell you what that meant. We're going to convert this to minutes, and we do that by timesing by 60 minutes in an hour. So here we times by 24, here we times by 60. So I'm going to come over here, 0.79, so I have 8 days, 9 hours, and then 0.79 times 60 gives me 47.4 minutes. So I'm going to say 48 minutes, rounding up. So this is an example of a problem where the translation and solving was relatively simple formula, easy to get the number, but the interpretation that they asked us specifically to do in days, hours, and minutes was difficult. We needed to convert it to hours, or we needed to convert our hours to days, and we first needed to check what actually our units were in. So we had to solve and figure out that we were talking about hours. We then needed to convert those hours to days. We needed to convert the decimal back to hours by multiplying by 24. That gave us an hour with a decimal. And then we had to convert that decimal into minutes by multiplying that by 60. And that gave us our final answer. So there are 2 practice problems here for you to try. This first one uses the compound interest formula. So it gets you practice doing that. This second one is very similar to this, where you're going to have to convert to just hours and minutes, though, not days for this problem. So you're just doing hours and minutes. And in this example, if you're an astute reader, you'd know that I just accidentally copied the same example twice. So this is exactly the same as what we just did. So that means this is the end of 2.5 and 2.7 formulas and word problems.